All right, welcome back, guys. So in this is 6.2 video, we're gonna look at how to add and subtract rational expressions. So it's a little bit trickier than multiplying and dividing rational expressions, because we have to make sure that we have the common denominator before we can add and subtract them, just like adding and subtracting fractions. Right, so if we take 3/4 plus 7/4, these fractions have the same denominator, so that becomes 10/4, right? But if we have 1/2 plus 3/7, we can't really add them because they don't have common denominator, so we have to make sure that they have the common denominator. And then 7 plus 6/14, which is 13/14. So it's going to be the same concept with rational expressions. So we're going to make sure the denominators are the same before we add the numerator or subtract the numerator. Let's start with the easy one here. So in this case, we have the denominators x are the same, so we'll just take the numerators and add them. So that gives us 9 plus x over x. Now keep in mind that the x don't cancel out right here. Okay, they don't cancel out because you need to have a factor on the numerator and denominator. So x itself is not a factor on the numerator because it's just x plus 9. It's not saying that x times 9. So we can't cancel out the x that way. Here, if we're subtracting, we got to make sure that we are subtracting and show that it is subtracting a quantity. So that means we have to put the parenthesis around the quantity, which is x minus 2. So that becomes 4x plus 5 minus x plus 2 over x plus 3. 3x plus 7 over x plus 3. Okay. All right, so that's an easy example because the denominators are the same. So let's look at least common multiple. Okay, so this is LCD. Okay, let's look at just these terms. So we got 21x and 7x squared. So it's not greatest common factor. Least common multiple means what is the smallest multiple of both 21x and 7x squared. Meaning what is the smallest number that both 21x and 7x squared divides into. Okay, well, we know that the LCD, so we know that, let's just go ahead and look at this individually. So 7 times 3 times x, 7x squared is 7 times x squared. We know that the numbers of both this divides into, which is the LCM, must contain both of these number factors, and that is 3 and 7. Those are the factors, and it also contains x and also x squared as well, right? So the LCD in this case is 21x squared because both 21x and 7x squared divides into LCM. Okay, so that's just with monomials. With trinomial and binomial, we need to factor them first, meaning in order for us to find a polynomial that is an LCM of these two polynomials, we need to make sure that what kind of factors these two polynomials consist. All right, so we say, all right, x squared plus x minus 12 is factored into x plus 4 times x minus 3. X squared minus 16 is x minus 4 and x plus 4. So the LCD, the LCM, must consist the factors from both of this. So it must have the factor of x plus 4 and x minus 3 and x minus 4. So we're looking at x plus 4, x minus 4, and x minus 3 is the LCD or LCM polynomial that both of these polynomial divides into it. Okay, so we said, right, so must contain, we said must contain both polynomials factors. Okay, so that's the requirements for the LCM. Let's do an example with monomial denominator, and then we'll do one with polynomial. Okay. All right, so here we got 3 over 10x squared minus 7 over 15x. So the denominator are not the same, so we have to find the LCM that helps both 10x squared and 15x can divide into, and then turn each of those denominators into the LCM or LCD in this case. So let's do it. So what we can do is we can look at this and factor them out and see, what we get here. right? So the LCM must have both of these factors, so they must contain x squared, must contain 3 and 5, and 2 as well, okay? So what we can do here is we can try to play match. So we can say that, all right, well, what do I need to do to make these two denominator match? Okay, well, let's start with the variable. This one has an x squared, this one doesn't, so we can times it by x. But if we time the denominator by x, we need to times it by the numerator as well. So top and bottom, so times by x. And then this one has a 5 already. This one has a 5, so we're good there. This one has a 2. This one doesn't have 2, so we times by 2 there. And then this one has a 3, but this one doesn't have a 3, so times by 3. But we need to times with the numerator as well. So there it is. So if we do this, we get 9 over 30x squared minus 14x. 7 times 2 is 14. And then 30x squared in the denominator. So we have matching denominator. We can subtract the numerator. And then we get the answer as that. Okay. Alright, so let's do one with the binomial and trinomial denominator. Something like this here. Okay. Alright. So z plus 3, z squared minus z minus 12. They're not the same. So we gotta make them the same or find the LCM that works for both of them. So usually we'll start with factoring these out first. Z plus 3 doesn't factor further, but z squared minus z minus 12 can factor, so that becomes z minus 4 times z plus 3, right? So to make this works, now notice that this one here has a z minus 4, this one doesn't, so we're just gonna go ahead and times by z minus 4. And we have the matching denominator. So that's all we need for this one, really. So we have z minus 4 times z plus 1 minus z plus 17 all over the common denominator, in this case is z minus 4 and z plus 3. So now we simplify. Z minus 4 times z plus 1, that becomes z squared plus z minus 4z minus 4, and then minus z minus 17 for this one here. Distribute the negative. Excuse me. Over the denominator. Okay, so let's simplify the numerator. We have what? We have 1z, negative 4z, we have another z. So we're looking at z squared stay the same. We're looking at negative 4z next because z and negative z cancel out. And then we have a minus 4 and minus 17. So that becomes negative 21 over z minus 4 and then z plus 3. Let's try to factor the numerator and see if things cancel out. The numerator factor into z minus 7 and z plus 4. And looks like things doesn't cancel out. There's no common factor for us to cancel out. So we'll just leave the answer as that. Okay. So that's how we add and subtract polynomial. We look for the common denominator. The objective is make sure the denominator is the same, and you just multiply the appropriate missing factors to make sure they're the same. And simplify the numerator after that, and then it should be good. All right, it's going to take some practice though.